So for this video, we're going to review our linear regression and types of questions that they're going to ask you about that regression model that you find. Unfortunately, I do not have access to a calculator that I can put on the screen, so we're just going to review over our steps and some things that you're going to see on the quiz and on your final exam dealing with linear regression. So as soon as you get your calculator, okay, especially if you're using one that is provided by the school, okay, you've got to make sure you turn on your diagnostic and turn on your stat plot every time you go to do your regression. So to turn on your diagnostic, you're going to go second, 0 to get to your catalog. Okay, second, 0. Once you're in your catalog, you can just scroll down until you see diagnostic, or you can skip straight to the D section because it's alphabetical by pressing the X to the -1 button. Above that, you'll see a capital D in blue, which means it's going to just take you to the D's. Alright, so we can go down and find diagnostic on. There's a diagnostic on and off. We want the on, and then you're just going to press enter 2 times. And when you're finished, it should say done on your screen. Then we got our diagnostic on. That's going to allow us to see that correlation coefficient. Okay, we also want to turn on our stat plot so that when we go to graph and we tell our calculator to adjust the window, it knows which plot that we're using. So to turn on your stat plot, you just go second, y equals. And it's going to have the option where it'll say 1, and then, it'll say plot. And something dot, and it'll either say on or off. We want it to say on. Okay, if it doesn't say, if it says off, we're just going to go enter to open up that plot. And then you want to highlight on. You can press enter again once you highlight it, and then your stat plot's on. Alright, so you got to make sure these two things are on every time. Just go ahead and get used to it, especially if you clear your calculator. Turn these two things back on. Then we want to enter in our data and look at the scatter plot. Okay, so remember you have to have an X and a Y. Your X is your independent variable, so it's what is the steady increase or kind of what the other one depends on. Alright, so we're looking for our X's and our Y's. We're going to press the stat button because we're doing all of our statistical analysis. So we're going to go to stat, and then you want the first one where it says edit, and press enter. That's going to take us to our columns where we have L1, L2, L3, L4, and so on. These are the two columns that we care about. L1 is going to be the X values, L2 is going to be the Y values. Make sure you have the same number of values in each column. If you don't, you're going to get an error. Once you have them entered in and you want to look at your scatter plot, you're just going to press zoom and scroll down to number 9, or just press number 9, and where it says zoom stat. And that's going to automatically go to your graph, and it's going to have the window adjusted so you see all of your points in your plot. Finding the equation. So now you want to find the line of best fit. So we're going to press the stat button. And then you're going to scroll over to calc. Get to the calc menu. And all we've been looking at so far is linear regression. So we're going to go to number 4 where it says lin reg. Right, and you press 4 or scroll down and press enter. And if you have an 83, you're going to just press enter again so it shows on your screen. If you have an 84, you just scroll down to calculate and press enter and then let it load. Right? Whenever it loads, it's going to come up with a screen where it says y equals ax plus b. It tells you what the equation you're modeling looks like. Then it's going to give you your a and your b, and then it's going to give you your r squared and your r. Okay, you just have to take your a and your b and plug them into ax plus b, your slope-intercept form, where a is your slope and b is your y-intercept. The r squared and r, we just use the r for our correlation coefficient to see how strong our correlation is, if it's a good fit or not a good fit. And then we're going to paste that equation into y equals. Alright, remember whenever you go to paste, it's got to be the last thing that you did on your calculator, the last equation that you found, so that your calculator knows that's the one you're trying to paste. Go to y equals, make sure there's nothing in there, clear out anything that's in there at that time, and then we're going to go to vars, and we're going to go over to, down to statistics. And then we're going to scroll over to EQ for equation. And we want that first one, regression equation. And that's going to paste the exact equation that we found using the calculator into y equals. And so we don't have to sit there and worry about rounding too soon. It takes the most exact that it can and pastes it into y equals. Then when you go to look at your graph, you should see your pretty line that goes nicely between all of your points. And it's kind of like an average line, your line of best fit. Then you're going to have questions about predicting. That's the whole reason that we do this linear regression. We take points that we have, data that we've collected, and we find this line that will let us predict maybe in between points or in the future. Okay, so whenever you're given an x and you are looking for y, so you're given the x. Okay, algebraically, one option algebraically is to plug in the x into your equation. And you could do that by hand. Whatever your equation was, just plug in your number for x. Okay, now keep in mind sometimes that might be rounding very early. Okay, but that's okay, especially if it's multiple choice and you have answers that are kind of far apart, you'll still get close enough to the correct answer. Okay, the other two options are using the calculator. Option number 2 is to trace. Right, so when you're looking at your graph, so you're at your graph window, you just press the trace button. And that's going to allow you to type in x values into your graph, and it's going to tell you the y. Now keep in mind, you have to scroll up or down and make sure it says y1 equals whatever your equation is in the top left corner. The first time you press trace, it's going to show P1, which is talking about the plot. It's got to have the equation because that's what we use to predict. And then once you have y1 in the top corner, you just type in your x value and press enter. Right? The other thing to keep in mind with this, you will get an error if that x value is outside of your window. So if you get an error, you may have to adjust your window, which just means you press the window button and type in your x max that you need it to be, or your x min. You've got to have that x value within your window. And our third option, right, which works if I have an integer for x, no decimals, no fractions, is to look at your table. Okay, so we would just go to second graph, which would take us to the table for whatever equation you have typed into y equals. If you don't have anything typed into y equals, you'll have a table with just x values and not y values. So you're going to go to second graph, it'll give you your table, and then if you need to, if you're looking for an x value that's really large, your table is going to take you to 0. So it's going to start around 0. If you want to look for something like 35, and you don't necessarily want to scroll all the way down to 35, you can adjust where your table starts. And that's by going to second window, right? And you don't have to do this. This is just if you need to. Second window, and that's going to take you to your table set. And in the very beginning, the very top line, you're just going to type in whatever you want it to start at. Okay, it'll say your starting point for your table, and you type in 35 or 45, whatever number you're looking for. Then you go back to second graph, and it's going to adjust your table to start where you want it to. Alright. And the other type of question is when you're given y and you're looking for x. So now, instead of giving the x to be able to plug in, I'm given y. Again, algebraically, you can plug in y for your equation. So take your equation and set it equal to whatever that y value is. But that could be rounding kind of prematurely. So to do it on the calculator, you're going to go to y equals, and then in y2, type in whatever y value that is. So if you want to predict x when y is 40, you would go to y2 and type in 40. So now you've got your line of best fit equation in y1, your new y value in y2. Then when you look at your graph, you're going to see two lines that intersect. You're going to see a horizontal line and then your slanted line that you found your equation for. All right? You want to find that intersection. That's where your solution is. So to find the intersection, we're going to go to second trace to get to our calc menu. Then you got several options there. We want to do number 5 where it says intersect. And it's going to ask you 3 questions. First curve, second curve, and guess. Your calculator knows what it's looking for, especially when we don't have 2 lines in there. So for all that we're doing, you're just going to press enter 3 times. And your calculator will be able to figure out what you're looking for. So you press enter 3 times, and then it's going to say x equals something, and y equals whatever that value is. Your answer is whatever the x is. We've also talked about correlation and causation. Okay, correlation goes back to that correlation coefficient. That's what tells you if it's a good fit for your data, for that line of best fit that you found. All right, that correlation coefficient can be between -1 and 1, and it can be equal to them. Okay, the closer it is to -1 and 1, the better fit it is. If it's close to 0, it's not a good fit. So remember, you can have a strong correlation, weak correlation, or no correlation. And then you could have a positive correlation, if it's got a positive slope, or a negative slope. And then you have no correlation if it doesn't show any sign of a line. Okay, and then causation is when you have one variable that causes another variable to happen. Not every example that has strong correlation means it's not necessarily a causation. All right, like for example in class we talked about the firefighters. Right, just because you have a lot of firefighters at a fire doesn't mean the firefighters are not what makes the damage cost so high. Okay, the fire itself is what causes both of them to be high, but the actual firefighters had nothing to do with the damage. Alright, so causation just means that one variable or one of your options causes the other. And again, not every situation is causation.